Okay, this is going to be 8.3, and I'm going to do more examples of what we did in class. So we did ABCD in class today, or it is still today. On Friday, we did ABCD. We proved that it was a parallelogram. All right, so now we're going to look at EFGH. Is EFGH a parallelogram? Explain how we know. So remember, to prove parallelogram, we need to know opposite sides are parallel and congruent. All right, that's what we need to prove. Okay, so first, if these coordinates are kind of hard to see, E is 5, 2, 15, 0, H is 2, negative 7, and G 13, negative 9. Okay, 13, negative 9. There we go. So let's start with parallel. So is EF parallel to HG? For lines to be parallel, their slopes have to be the same. Okay, I'm going to go ahead and just do it here so that I don't have to move my screen. So we're not doing ABCD. We're doing, actually here, let me, every time, I don't know why. Okay, we're going to do this one instead of ABCD. All right, but that way I don't have to move my screen down. So, is EF parallel to HG? So EF, what is the slope of EF? Okay, well my change in Y, I'm going from E to F. So my change in Y goes from 2 to 0. I go from 2 to 0. So my change in Y is negative 2 over my change in X, which is 5. I go from 5 to 15. From 5 to 15. 5 to 15. So that is 10. So that's my change in Y over change in X. We could reduce that if you wanted to. Negative 1/5. Okay. HG. Slope of HG. Change in Y over change in X. So let's see. H is at negative 7. We're going to change in Y. So it goes from negative 7 to negative 9. That is negative 2 over my change in X. From H to G, my X goes from 2 to 13. Is that right? Yeah, 2 to 13. So that is from 2 to 13 is 11. Goodness gracious. Oh, so are these slopes the same? Is negative 2 over 10 the same as negative 2 over 11? No. EF and HG are not parallel. Therefore, EFGH is not a parallel. So you can stop there. Just for practice, let's do the other side. Let's see, is EH, so now we're going to do, switch my color, red. Oh, now it's going to be all Christmassy. Oh well. Is EH parallel to FG? Okay, we're just doing this for practice. So EH, the slope of EH, my change in Y. well, let's see, y is at -7, and I go up all the way to 2. From that should be -7. Sorry. -7, and it goes all the way up to 2. So that is 9. Change in y is 9 over my change in x. I have 2 to 5. 2 to 5, so that's 3. If you want to reduce it, 9 divided by 3 is 3. So that's your slope of EH. Let's find the slope of FG. My change in y. Okay, well, I'm down here at -9. Y is -9, y is -9, and I go up to 0, from -9 to 0. All right, so that's +9. Over my change in x. Well, my change in x, my x is at 13, and it goes to 15. From 13, x is 13, and it goes to 15, so that's 2. So once again, is the slope of 9 over 3 the same as the slope of 9 over 2? Are these the same fractions? No. No. EH and FG are not parallel. So therefore, EFGH is not a parallelogram because opposite sides have to be parallel. Okay. We did this one in class, so let's go ahead and do ABCD. We're trying to prove it's a rectangle. So let me see. A is at, oh my goodness, -8, 13. B, goodness gracious, 2, 13. C is 2 and 9. And D, -8 and 9. Okay. So rectangle. It's something to prove that it is a rectangle. Again, opposite sides must be parallel and congruent. And that would make it a parallelogram. Opposite sides are parallel and congruent. That's a parallelogram. If it's also going to be a rectangle, all angles are 90 degrees. Okay. I don't know. You can kind of start wherever you want here. Let's see. Is side, I don't know. Is side AB equal to side DC? Okay, opposite sides need to be congruent. Well, how long is side AB? They're both at y equals 13. So I'm going from -8 to 2. So from -8 to 2, that is 10. So AB equals 10. DC equals, my y values are both 9, so I'm just going from -8 to 2. Oh, okay, well, 10. They're both 10, so yes. AB equals DC. What about my other sides? AD and BC. Are they congruent? Are they the same length? Well, this one goes from, my x values are the same, so it goes from y is 13 to 9. So 13 to 9, so that's a length of 4. AD equals 4. What about BC? What about the length of BC? 13 to 9, also 4. Okay, so yes, they are congruent. Woohoo! Okay, they must also be parallel. Are opposite sides parallel? Yes. I mean, you can, to prove it, let's do the slope of AB. Slope of Okay, my change in y is 0. So my slope is going to be 0. If my change in y is 0, then my slope is just 0. 0 divided by any number is still just 0. 0 divided by any number is still just 0. So it doesn't even matter what my change in x is. If my change in y is 0, my slope is 0. But if it makes you feel better, you can figure out the change in x, which we already figured that out. It's going to be 10. I'm going from -8 to 2, and that is 10. Okay, but it doesn't matter. 0 divided by 10 is still just 0. So the slope of, that was AB, DC. Change in y is 0. It stays at 9. So your slope is also 0. So they have the same slope. So AB and DC have, hold on, a slope of 0. So they are parallel because they have the same slope. Okay, slope of AD. My change in y is going from 13 to 9, so that's -4, over my change in x. -8, -8. So I have -4 over 0. You cannot divide by 0, so that is undefined. You cannot divide by 0. So this slope is undefined. Slope of AD, BC. Change in x, you're going from 13 to 9, so that is, sorry, change in y, you're going from 13 to 9, so that's -4. Change in x is 2, so it's 0. So once again, you cannot divide by 0. It's also undefined. So they both have undefined slopes, which means they have the same, which means they're parallel. Their slopes are undefined, they are parallel. So they are parallel. All right. Last thing you need to do is figure out, are all your angles 90 degrees? That means when these lines connect, do they form right angles? Do they form 90-degree angles? It looks like it, but we have to prove it. I'm going to get rid of this. Boom. Here we go. So, in order to be a rectangle, AD has to be, I wish I didn't get rid of that because we had the slopes perpendicular to AD, perpendicular to AB. AD has to be perpendicular to AB and to DC. It has to be perpendicular to these lines. Well, horizontal and vertical lines are perpendicular to each other. So we could just say, yes, it's a rectangle because horizontal and vertical lines are perpendicular to each other. Or if you remember the slope of makes it kind of, okay, so the slopes of AB and DC were 0. Slopes of AB and DC, AD and BC were undefined, which means they were were 0 over some number. No, I don't want to go into this. It's kind of flipped. This time, this one, slopes of AB and DC were 0 over some number. Undefined means 0 is now on the bottom. So they are flipped. But I'd rather you just say that horizontal and vertical lines are perpendicular to each other. Okay, remember, if I were to draw in lines on this really hard to see grid, my x-axis is vertical. If I were to draw in a horizontal line, let's say along this guy. Doop. That's not straight. We actually do it straight. Okay, if I were to draw it, I could draw in horizontal lines, okay, and they would all be perpendicular to my vertical line. Okay, as long as they are straight. Straight. Okay, horizontal and vertical lines are perpendicular to each other. So, yes, ABCD is a rectangle. We did that one in class. All right, the next one. Is ABCD a rhombus? Explain how you know. Where is it? Oh, this is one. Okay, so ABCD. Here we go. A, 9, 8. B, 9, 2. C, 3, 3. 1, 2, 3. Yeah, 3, 3. And D. I lost it. Oh, 3, 9. Okay. So to be a rhombus, opposite sides are parallel, and then all sides are congruent. Congruent. So opposite sides have to be parallel. All sides have to be congruent. Okay. So we can, I don't know. I never know where to start. You can start anywhere. Let's start with, is DA parallel to CB? Okay. So let's find the slopes. Their slopes have to be the same. So my slope of DA is my change in y over my change in x. So my change in y, I'm going from 9 to 8. Okay, fair enough. Change in y is 1. Oh, negative 1. My change in x, I'm going from 3 to 9. So that is from 3 to 9, 6. All right, so my slope of DA is negative 1, 6. What about my slope of CB? Change in y, I'm going from 3 to 2, from 3 to 2. All right, that's fair enough. That's negative 1 over my change in x. I'm going from 3 to 9. Oh, it's the same. So it's also negative 1, 6. All right, so my slopes are the same. My slopes are the same. That means this line is in fact parallel to this line. Oops, sorry, that got away from me. Okay, cool. So okay, DA is parallel to CB. Now we need to try the other set of lines. Is DC parallel to AB? Okay, your other set. So let's find the slope of DC. So DC parallel to B, question mark. Okay, my slope of DC, change in Y, 9, and I'm going to 3. 9 to 3. 9 to 3. That's negative 6 over my change in X, 3 minus 3, okay, 0. So once again, this is an undefined slope. Undefined. So in order for them to be parallel, this one also has to be undefined. So is my change in X 0 on AB? My change, sorry, my change in Y is once again negative 6. My change in X, 9, 9 is 0. So that's also undefined. You cannot divide by 0. Undefined. So they are parallel. Oops, parallel. All right. Now, they all have to be, so everything that needs to be parallel is parallel. So opposite sides are parallel, we can check that off. Are all sides congruent? Okay, so now we have to find the length of all the sides. So let's start with the easier ones. Let's figure out DC. What is the length of DC? Here, let me get rid of my lines. We're looking at DC. What is the length? Well, my x value doesn't change, right? So I'm just going from 9 to 3. You can even count it. 1, 2, 3, 4, 5, 6. Or you can go 9 minus 3 is 6. So my length of DC is 6. Okay. What about, go to AB. What's my length of AB? Once again, you could just count it. 1, 2, 3, 4, 5, 6. Or my x values are the same, so I'm just looking at my y's, going from 8 to 2, which is also 6. All right, so those check out, but they all need to be the same. So now we need to find the length of DA. Length, sorry, let's do that. DA length. Okay, now we have a slanted line. So you either have to use your Pythagorean theorem or your distance formula. So I'm going to use my distance formula. My computer wants to start dying on me. I don't want to get up to charge it. Let's see if we can do this. Okay. So my coordinates are 3, 9, and 9, 8. 3, 9, and 9, 8. 3, 9, and 9, 8. Oops, sorry. 3, 9, and 9, 8. Okay. Come on. There we go. So my distance formula is the change in y. Here, y2 minus y1 squared, plus 2 minus x1. Okay. We can substitute y values in if you want. So, well, I don't know. We'll make this be y2. So I have 8. No, actually, that's fine. 8 minus 9. 8 minus 9. 8 minus 9 squared plus my change in x. 9 minus 3. 9 minus 3. Quantity squared. Okay. Simplify. 8 minus 9 is a negative 1. Quantity squared plus 9 minus 3, 6. Squared. Keep going. Negative 1 squared is 1 plus 6 squared. 6 squared is 36. So you get the square root of 37. All right, square root of 37. So that is whatever length we were figuring out. Uh-oh. Hold on 1 second. I have to pause you. I think I messed up. Never mind, we're good. So you get the square root of 37, which if you reduce that, it's like 6 point, what did I just get? 08? 08. So they are, wait, where to go? Wait. Okay. So these guys have a length of 6. This one has a length of 6.08. So that's really obnoxious. It's incredibly close to being parallel, but they're not exactly, sorry, not parallel, congruent. It's extremely close, but they're not quite congruent. Okay, this one is 6.08. This is only 6. So this is, So DA is slightly longer, okay? And CB is going to be the same length as DA. So these sides are just a little bit longer. So technically, we don't have a rhombus here. Ugh. Okay. So technically not a rhombus. So no. Technically not. Technically not. Sides DA and CB are slightly longer. If you want to be exact, actually you can't be exact, but it's about 0.08 longer than AB and BC. All right, so then you have EFGH, so you would go through the same process to prove is it a rhombus or not. Okay, so opposite sides have to be parallel, and all the sides have to be the same size. The last one you have is ABCD a square? Okay, to be a square, it has to be both a rhombus and a rectangle. Okay, a square is both, and it's a rhombus and a rectangle. So that means opposite sides are parallel, all sides are congruent, and you have that 90 degrees. Oh wait, sorry, all angles. Okay, we haven't done a lot with the whole proving the 90-degree thing, so I'm going to start there. I might not do this whole problem. So, all angles have to be 90 degrees. So that means that DA has to be perpendicular. DA must be perpendicular to both. DA has to be both perpendicular here, so to AB, and BC. Okay, because it needs to form right angles. So these two lines have to be perpendicular, so do these two. Okay, and also same thing over here. CB, I guess I just add that here, huh? It's not going to let me. Maybe it will. Oh well, CB and DA must be perpendicular to both AB and DC. Okay, so they have to be perpendicular. To do that, you're going to use perpendicular slopes. So let's find the slope of DA. Sure. Slope of DA. Right, so what is my slope? My change in y, I start at 9 and I go to 2. I'm going from 9 to 2. So that's 7 over my change in x, 3. I'm going from x equals 3 to x equals 7. X equals 3. Oh, that should be negative 7. I'm sorry. 9 to 2 is negative 7. 9 minus 7 is 2. Okay. 3 to 7 is positive 4. 4. All right, so the slope of DA is negative 7 over 4. So, is that perpendicular to AB? Well, let's find the slope of AB. To be perpendicular, the slope has to be the opposite reciprocal. So it has to be 4 over 7. That's what we're looking for. So is the slope of AB 4 over 7? You flip it and you switch the sign. Let's see. AB, my y value, I start at 2 and I go to 6. So my change in y is 4. That's looking good. So far it matches up. My change in y, oh sorry, that was my change in y. Right, did I say that? My change in y is 4. I go from 2 to 6. My change in y is 4. My change in x, I start at 7 and I go to 14. 7 to 14, that is 7. Oh! So they are in fact perpendicular. All right. let's find the slope of, really we're just going to find the slope of all four lines. So the slope of DC. So the slope of DC needs to also be 4 over 7. So let's see, my change in y, I go from 9 to 13. Okay. That's 4. And my change in x, I go from 3 to 10. That is 7. All right. And then I'm going to find the slope of my last line. Slope of, what did I do? Oh, CB. CB. Okay. Change in y. Y is 13. I go down to 6. 13 minus 6. 13 minus 6. So I'm going down 7. 13 minus 7 is 6. So my change in y is negative 7. My change in x, I'm going from 10 to 14, is 4. Oh, we actually just proved a lot by finding the slopes. Okay? They are, in fact, perpendicular to each other. See how they're opposite reciprocals? So AB and DC are perpendicular to these two because they have opposite reciprocal slopes. Do you see that? DA is perpendicular to AB and it's perpendicular to DC. They have that opposite reciprocal slope. Same thing down here. CB is perpendicular to DC and AB. Let me get rid of this. So we can check off the perpendicular. We can check off the 90-degree thing. We figured that out. Yes. Okay. We also, by figuring out the slopes, found out that opposite sides are parallel. DA needs to be parallel to CB, which means they need to have the same slope. Opposite sides need to be parallel. So does DA have the same slope as CB? DA, CB. Yes, it does. And then DC to AB. Opposite sides need to be parallel. Is AB parallel to DC? Yes, it is. They have the same slope, so they are parallel. So we just proved perpendicular, or whatever, 90 degrees, and we just proved parallel. Yes. The last thing you need to figure out is are all sides the same length? Okay. So you're going to be using your distance formula. So we already have the change in y and the change in x because we have our, right, we just wrote all that down. So let's find the length of dA. Length of dA. So my change in y is negative 7. My change in x is 4. Okay, here we go. There we go. Okay. I forgot what I said. My change in y is negative 7. Change in x is 4. Negative 7 over 4. Okay. Change in y is negative 7. So that's negative 7 squared plus 4 squared. Change in y, change in x. Okay. Let's see if we simplify. Negative 7 squared, 49. This 4 squared, 16. Equals, that's fine, we'll just keep going with it. 49 plus 16. 65. So you get the square root of 65. Okay, we're going to leave it there. So the square root of 65. Oh. I'm drawing my square root sign. Okay. And then you might be able to tell already, but you can use the distance formula for the next three, and they all will have the same length, which means this is indeed a square. Okay, so for AB, your change in y is 4, your change in x is 7. Same for DC. CB, your change in y is -7, change in x is 4. You're going to get the square root of 65 for all of them, so it is indeed a square. Whew, okay, hopefully that helped if anyone needed the extra